So, welcome everyone to the grand finale round of Repulsion 2021. For the first match, we have Faraday's cage who will be going against Kepler's orbit. And the motion for the debate is, will faster than light travel will ever be a possibility? So Kepler will be the government for this debate and Faraday's cage will be acting as an opposition. So, shall we commence with the debate? Are the judges ready?
Yeah, the other judges.
Okay.
I'm
So,
the first.
Ashish, over to you. Since you're the chair of the debate.
Thank you, Jay. Welcome to all the participants and good luck to you. We'll begin the debate. We'll have, first off, I hope everyone knows the rules and everything. You know the time limits and everything. You've participated in the debate yesterday also. So we'll have the first speaker from the proposition speaking first. You can start whenever you're ready.
Yeah, I just wanted to know how will they raise the POIs? Like they'll raise their hands or whatever. Can you, like, anyone can let me know first? How will you?
We
do that?
unmute and say
Okay,
POI.
cool. Yeah.
One hand raised and POI once. That's it.
So I'll start. 1, 2, 3. A very good afternoon to everyone present over here. Being the first speaker of the government today, we believe that faster than speed of light travel is possible. Today, I'll be talking about the ways and the technologies in which this is possible. The speed of light, traveling more than speed of light is possible. And I'll be telling you about, for example, the wormholes and the warp drive technology. And the second speaker of the proposition will be further elaborating on the subject. First, I want to make it very clear and I want to explicitly state that whatever we have, the topic is not only about our universe, and neither it is about the humans. It is about a bigger picture. So today we'll be talking about the bigger picture. So I just want to make it clear that it is not about our universe or us. So firstly, whatever our other arguments are, it is only on the possibility that the speed of light is not possible if we talk about the laws that we know, about the laws that we know, for example, the general relativity. But I'll be further explaining that. But as I told you, we'll be talking a bigger picture. We'll be looking at a bigger picture. So firstly, in 1994, okay.
Can you please define bigger picture clearly and succinctly?
Sure, I'll do that as my speech starts. In 1994, a scientist, Miguel Eliber, said that faster than speed of light is possible if the bending of fabric of reality is possible. As in, if the bending of the space and time is possible, which means there are technologies which we do not know at this time, but there are technologies. So the first one being the warp drive technology. I guess everyone is aware from the space Trek and other animated movies like that. So the thing is, it is not known by us. We haven't discovered it right now, but if this topic is in itself a theoretical topic, so we cannot say that this is not possible. Everything is possible.
POI.
Sure.
What kind of theory would go into a warp drive, if you can explain?
Yeah. So warp drive basically is it is based on the general relativity, and what is actually is, it is like we are traveling, we have a bubble and we are pushing ourselves forward, and which as it means that we get a flat surface and we are actually pushing forward, which means that we will be traveling faster than the speed of light. Another possibility, as I am sure the opposition will quote, wormholes. I'm sure the opposition will quote about the Einstein general relativity, and being the fan of Einstein, they would surely say that it won't be possible as general relativity, or for example, special relativity won't allow it. But I want to put this point: wormholes. It is a special solution of Einstein's field equation, also known as Einstein-Rosen bridge. What it is actually, it connects long distances. It is The 2 points in space are connected by long distances, and it can connect billions and trillions of light years or even different universes. So in 1995, Matt Weiser suggested that there may be many wormholes in the universe if cosmic strings were negative mass were generated in every universe. So now, when I am talking about every universe, I have to quote string theory here. I have to bring string theory here because I know string theory is a very major topic right now and a subject of research right now. Many physicists like Brian Greene and Michio Kaku are currently talking about, and they have spent their lives on
1 minute
on
left.
string theory. So what string theory suggests? It suggests that there are multiverses possible. And so as I have quoted earlier, that whatever we are saying, it is not about only our universe, and it is not about only us humans. It is about a bigger picture, which means a multiverse is possible. And if in a multiverse, and as I quoted, Matt Weiser suggested that if there are negative mass in the cosmic strings, so it is possible. Another things being tachyon, for example, a hypothetical particle that allows travel, which is a hypothetical particle, which is suggested that it can travel faster than the speed of light. But the only point why scientists not believe, why physicists don't believe it, because they say that it is inconsistent with the laws of physics that we know exist right now. But I told you, we are not talking about the only laws. And another being the extraterrestrial life forms that there are. I am sure aliens sound very ridiculous, but we cannot just neglect this. So talking about all of this and suggesting the
5
wormholes,
minutes over.
about the extraterrestrial life forms, they're possible, about the string theory and warp drive technology and wormholes. I suggest and I strongly, at my favors what I said. So I believe, and we strongly believe, the government strongly believe that faster than speed of light is possible. Thank you.
Thank you, Speaker 1. We'll move on to the opposition Speaker 1. You can start whenever you're ready.
Okay, am I audible clearly?
Yeah, we can hear you.
All right. Good evening, respected judges, my worthy opponents, and all present here. Today, we, the opposition, are going to speak about how we firmly believe that, unlike what the government is trying to say, faster than light travel is not possible. And here's how we will prove our stand. I will speak about special relativity and general relativity, how it holds experimentally, and will also bring up some of the points that the first speaker mentioned. Saurabh, a second speaker will present experiments which try to, he will speak about experimental, experimental side, and a third speaker will concretize our arguments and frame our theory properly. Okay, so we begin with Einstein's special theory of relativity. It starts with just two simple postulates, that the frames of reference are same. I mean all same frames of reference are equal to each other, and that the speed of light is constant in every inertial non-accelerating frame. So the thing here is that if in Einstein's theory of relativity, if we try to accelerate a particle or any object close to the speed of light, what happens is that you keep needing an increasing amount of energy. Like when you're really close to the speed of light, you need a tremendously high amount of energy, such that it's a simple formula: gamma equals gamma mc square, where if v is less than c, it simply cannot reach c. So that classically, at least, can completely rule out any particle going above c. As for the possibility of wormholes, I would say yes, wormholes are possible in theory and microscopic, but these are yet microscopic wormholes. There's no mechanism of how you would make a wormhole large enough for a spaceship to travel through. And for yes.
Okay, so how can we trust a theory? And Einstein being a great scientist, but a person who did not do the expansion of universe, how can we trust the theory on the whole world, on the whole universe?
Well, okay. I do not have something substantial to say to this exactly. Moving on. Warp drives, the point of warp drives that my opponent raised, the Alcubierre warp drive, basically it has some problems. The issue with it is that it speaks about short times and fast speeds, all right, but the metric in GR, the metric, the Alcubierre metric, it violates the energy, the weak dominant and the strong energy conditions, which basically means that it requires a negative energy density, which is not possible. And that could be possible with exotic matter, but that is really out there in the realm of physics. It's not something that has yet been proven, or and it might not be possible either. And another point is that warping, basically the whole argument is that you warp space-time around the not right now. You warp space-time around the spaceship, all right? So when you contract space-time, you need positive gravity, but for expanding space-time, you need a negative gravity. But this is not possible, again, because we know of no such particle which acts as a which repels gravity. Okay, yes.
So whatever you are saying, it is only based upon the fact that it is only possible in our universe. But what about multi-universe, as the string theory suggests?
Multi-universes, well, that would require different law. That might require different laws of physics. But right now,
1 minute left.
Okay, right now it might not quite be valid in our universe. And well, okay, I'll move on. So another thing is, okay, so the opposition could say that maybe dark energy or something like that could be the thing. But then again, dark energy is something that does not interact, which we know. So again, you cannot really pass that sort of argument. To conclude, I would just like to point out that Einstein's theory has worked. The special theory of relativity and general theory of relativity have worked very well in particle physics. There have been so many examples of times when you see superluminal motion, you think that there is superluminal motion in space, but at every time it has been shown that these are just because of our frame of reference in Earth. And yeah, that's all from my side.
Thank you, speaker one from the opposition. We'll have the speaker two from the proposition speaking next. You can start whenever you're ready.
Thank you, Mr. Chairman. First of all, before coming to my arguments, I would like to answer some of the questions and points raised by the first speaker of the opposition, in which they talked about the special theory of relativity. So, and they based their arguments that due to special theory of relativity, the travel faster than light is not possible. But the special theory of relativity applies to objects with mass. But how can we neglect the possibilities of any massless particles? Some time back, we didn't even believe even the things which are proved to us right now. In the past, we did not believe in that. We initially believed that Earth is the center of our solar system. Then we believed that time is same for everyone, for all observers. But with time, all these things have been proven wrong. And since we are a developing civilization, we learn new things each day. So we cannot neglect the possibility of massless particles in the future, and hence we cannot say that faster than light travel is not possible. The other thing, my first speaker of opposition himself said that. Yes, please go ahead.
Yes, may I ask the government that do they even have one single bit of experimental evidence to back their claim? Because the opposition has a lot.
Okay, so I will come back to that. So the second point which was raised by the first speaker of opposition was that it is only possible for a microscopic thing, and for microscopic things and like large spaceships, it is not possible to go through the wormhole. So my argument will be that microscopic, he himself said that faster than light travel is possible for microscopic birds. So it can be a possibility with in further research. By further research, it could be a possibility for macroscopic things as well. Yes, sir. I will take that later. Okay. I will take that later. Okay. So in the POI, I was asked that if we have any experimental observation which shows that a travel of speed faster than speed of light is possible. So here I would like to talk about the luminal blue. So when anything travels faster than the speed of sound, we experience something as a sonic bloom. And when anything travels faster than the speed of light, we also have seen luminal blooms. It was proved by as Cherenkov radiation. It was proved by a very famous scientist, Soviet scientist Pavel Alexeyevich Cherenkov in the year 1934, and he also won a Nobel Prize for that. It was observed near advanced test reactors in which electrons which were released by them traveled faster than the speed of light. Yes, sir, please go ahead.
Yes, but if I'm not mistaken, Cherenkov radiation is based on faster than the speed of light in a medium, supposedly like water or any dense medium. But it doesn't talk anything about vacuum.
Yes, sir, it is true that the Cherenkov radiation is based on other mediums, but the house believes that faster than light travel is possible. We have not restricted our motion to just vacuum. Thank you. These were some points which I wanted to raise, and if I would like to ask the opposition if they have any more POIs, and then I will come back to my second argument.
Okay, so my POI was that basically you said that particles, you countered my point saying that particles can travel. I said that particles can travel faster than light, but the whole point of the debate is faster than light travel, as in we are specifically talking about a spaceship traveling faster than the speed of light. What do you say to that?
Yes, sir. I would again say the same thing to that, that it is not, if not today, it is a possibility for tomorrow. And if for microscopic world it is a possibility today, then for the macroscopic world, it will be a possibility tomorrow. The second thing I would like to give my argument is about the Big Bang itself. Yes, it is a very well-known and widely accepted theory that after the Big Bang, the universe itself expanded with a speed of light, with a speed which was greater than the speed of light. So that was all my arguments, and thus we believe in the philosophy of never say never. So we, the proposition, strongly believe that the possibility is very real, and we can someday travel with the speed greater than the speed of light. Thank you.
Thank you, Speaker 2 from the proposition. We'll have the Speaker 2 from the opposition next. You can start whenever you're ready.
Just a minute. Hello, am I audible?
Yes, you can start if you're ready.
Okay. I would like to counter, before I start my speech, I would like to counter my first government speaker. So he stated that we are the warp drive and the wormhole. So all the theories they would be suggesting for space travel, so for travel faster than speed of light, would not just for would not be for humans and would not be for this universe. So I would like to understand if they are talking about some multiverse or some other universe. Please tell us how we would be traveling to that universe, because for that we would need need to travel faster than speed of light, or else we would die before that. Later, okay, one of the POIs which I asked to the first speaker about what kind of technology or what kind of theory goes behind
minutes left
to creating a warp drive. He stated about I think special or general theory of relativity. But I would really like to answer like what would need the drive, like is there any scientific evidence, even a small hypothesis, like we would meet this higher warp drive with use of some particles, some fuel, some, let's say, come up with any theory, like any particle which is non-existent, and tell us that this would fuel the warp drive. to change the curvature of space and time to travel faster than speed of light. Okay, coming to the POI which was asked to my first speaker, uh, he never said about disproving the expansion of the universe. And we know that the expansion of universe is faster than speed of light, but this doesn't prove that we can travel faster than speed of light. And we actually do not understand does the expansion of yes.
Yes, you
Yes.
can go forward. Yeah, yes, you can.
100 years back, black matter and black matter wasn't known. So how do you say, if we do not know a theory right now, so how can you say that it is not possible after 100 years?
But how does this come up like in this question? Okay. Okay, I will get to your question later. So we never said about disproving the expansion of universe, and the POI was raised about supporting Einstein and disproving the person who came up with this idea. But we really do not understand what exactly how the expansion of universe is working. Because we don't know how it's expanding. It can be also for it's in multi-dimensional. We need to look into it. The first speaker even talked about tachyon, and as I have already stated my first question, like if we are not talking about this universe, then how we would be traveling into that universe which the first speaker is dreaming about? Because tachyon, they violate causality. They according to general theory of relativity, they violate causality, and tachyons do not respect the Lorentz invariance theory. Okay, coming to neutrinos. Yes.
So are you saying what experimentally it is not possible right now won't be possible after in future?
If anything is not possible right now, but there should be some theory, some bizarre theory which says about that there would be like a travel that would be useful in traveling than space at speed of light. But the main point of my debate is about how would we travel to another universe that the first speaker is talking about. And coming to neutrinos, coming to neutrinos, one experiment done by Opera, the experiment was done and called Opera. One of the this paper is published in journal Scientific American Journal. So it's so the ones which were checking it, does the particles travel faster than speed of light, stated that there was too much uncertainty in the detector's exact position to be sure of the significance of this experiment. Even okay, and I would like to quote from the similar paper which I have cited, that there are many experiments that have looked for particles traveling faster than speed of light in the past and have come with empty hands. I would rest my case.
Thank you, Speaker 2 from the opposition. We will move on to Speaker 3 from the proposition. You can start speaking whenever you're ready.
Am I audible enough?
Yes, we can hear you.
Okay, so I'm ready to go. Yeah. So a very good afternoon to one and all present here. It feels very happy to be here. We've gained a lot of information today from the opposition and proposition as well. But the points put forward completely by the opposition could be ruled out and was centered in one point, that nothing is possible other than the theories put forward till now, which is not something that's possible in science. Science has always opened its door to more information, more findings, and always disregarding the one before. We've always seen this school in colleges where we learn one theory and then we learn that, okay, it was wrong and this is the new theory. So we cannot rule away the fact that we can never come up with an experiment or theory laterwards. To answer or the rebuttal, the points which was put forward by the second opposition leader, is there any experiment which was put forward to see if anything could travel higher than faster than the speed of light? Let me take the Cherenkov radiation. which is a method of accelerating particles faster than the speed of light, and it works as a material in nuclear reactors. When water is surrounding it, it can move. Yes.
4 minutes left. Keep speaking.
Okay, yeah. So it can move faster than the speed of light. Now, this is one way we can do it. And then talking about, yes.
While defining the first speaker, while defining the debate itself, said that the government won't be talking about this universe, but would be talking about the multi-universe. And now again you have come back to this universe. So how do you define this? How do you explain this?
So like what he meant was like, not only we'll stay to this universe, we'll increase our I'm missing the word. We'll increase our experiment to other universes as well. It doesn't mean disregarding the universe we are at right now. And traveling to other universes, again, it is possible because we are at a stage where we are at 0.73 in the Kardashian scale, and we've always reached type 1 scale within the next 100 years or the next century. And there are many scientists who prove that out. So traveling to other universes is something impossible, is a very wrong or a very ridiculous statement we can make at this situation or at this stage where we have found many things from the past and we've improved so much. And we can take examples from everywhere that actually I'm sitting here, we're talking with each other on internet is also one technology we couldn't have thought about 100 years ago. So
POI.
that is one. Yes.
The government has again and again raised the question of future. In future, this can be done. Future, that can be done. But I may want to point out that even though internet is a new thing, most of the theory work had been done about 2 centuries back. And vis-a-vis this case, the government does not even have that much of theory work.
Well, I'd like to contradict that by a theory which was put forward by Lenz. I don't know if I'm pronouncing the word right, but he has put forward a theory where the conventional energy sources could be capable of arranging the structure of space-time in the form of a solid and singular wave, hence by which it can move faster than the light, which was happened. This was an experiment which was done in the year 1994, which is not 2 centuries ago, which is like nearby. And he could come up with the experimental value any day. And it is not that we're always accelerating. We're not moving backside. We're moving always forward. And I am pretty sure, we all are pretty sure that we would get more technologies than we have today. So not believing that or not believing in science is never going to be a reason that, yes, this may not happen. Science has always come up with the most impossible things, and we cannot rule out the fact that this may not happen. And all the arguments put forward by the opposition was based on the theories which were given by the scientists. And theories have always been wrong. We've always believed that Newtonian mechanics was something right. And there was a long debate on that, and now we don't believe in it. So technically ruling out things is not something that's new in science.
Are you trying? I'm sorry, POI?
1 minute left.
I think it's over 4 minutes are over, and I don't think you can put up a POI.
But my question was at 3.
I don't think you can do that. Sorry. So yeah, and then most of the answers to the questions put forward by the opposition was given. The answers were definitely given by the opposition speaker number 1, where he told that yes, different laws can also come up, which can bring a reason for accelerating particles or moving particles faster than the speed of light. He has also told that there are exotic matters which are possible to move. And then he's like, okay, maybe we can't move. Again, the word maybe doesn't mean that we can't do it. So we've always believed that science always have a room for exploration, more room for interesting and technological expansion. So one day we would definitely reach the aim where we can travel faster than the speed of light. Thank you and have a nice day. I think that's it.
Thank you, speaker 3 from the proposition. We will have the speaker 3 from the opposition, and you can start whenever you're ready.
Yeah. Good evening, everyone. I would like to point out a number of some words that I have heard from the government side. Trust, possibility, never say never. Yeah, the future, anything can be possible, but I don't think so. Physics runs on this principle of never say never, of possibility. Physics is not philosophy. Physics is pure science. Physics is based on hard facts, experimental facts, and theoretical facts. I think the government has been absolutely has been loose in defining their terms, because at the first they defined that and I also asked a PI, for which I got a rebuttal, that while defining the terms, they said that we are going to talk about multi-universe, and then they came back to the universe. So the PI return was that we are going to talk about both the universes. But I think the most of the focus of the government has been on multi-universe, for which we have no experimental evidence, and we are not only going to hold accountable the government. We are not going to hold the government accountable for only experimental evidence, but we also don't have that much of theoretical background work for that. Now let me let me quote some of the government speeches. When they say that the Earth was, we believed in Helios, and we believe that Earth was the center of the universe, etc., etc. Disregarding Newton and and the old theories. May I also point out that even today, when we do quantum mechanics, we use Lagrangian operators, we use Hamiltonian operators, and those have been there for from past three or four centuries. So the government clearly does not believe that the physics is built on the work that has been done before, and then the work that has been added right now, and we blend it, we experimentally check it, and this is how physics is done. Whereas the government completely is in the realm of speculations and speculations and speculations. Yes, go on.
So, like, are you trying to put forward the point that the new scientist cannot bring up with a new theory rather than blending?
No, I'm okay. I'm trying to point out that how you are completely disregarding the old and only basing your argument that there will be some future scientist who would disprove everything that we know from the past. Whereas we know that it doesn't work that way. Even Einstein built his entire theory based on few errors that Newton was not able to convince himself with, like space-time. Even Newton was not able to grasp the concept perfectly. But today, I don't think so that is the case. As far as special relativity and general relativity are concerned, they are proven experimentally as well as theoretically, and they are the cornerstones of physics. To say that one fine day everything will be overturned, it doesn't work that way. You will have to yeah.
We've seen that Newtonian mechanics was kindly very much disregarded. So how do you explain that the whole theory was told no?
No, absolutely not. The theory was not torn off. Actually, we use most of the Newtonian mechanics today, and I'm not just pointing out to engineering fields. Newtonian mechanics led to the development of Lagrangian mechanics, Hamiltonian mechanics, which led to the development of quantum mechanics. As I said, the government is completely confused on how physics happens, and I think that is a very risky territory to be. Sorry, you're out of time, I guess. Anyways,
1 minute left.
Yeah, anyways, to sum up the opposition point of view, the opposition is not against the ideas, against new ideas or new research, but the opposition is definitely against wild speculation and rumor mongering, to be honest. As my first speaker spoke, how special theory works, and he gave as my second speaker gave experimental evidence regarding that. The opposition is not in the space of rumor mongering. If you see, the opposition is in the space of facts, figures, data, evidence, experimental evidence, and even good theoretical evidence, which has sustained for over a century. And I don't think so we can just overturn it. Having said that, there have been countless experiments to disprove to prove that there can be faster than speed of light travel, but they have all failed. And this only points to one thing, that faster than the speed of light is not possible, and definitely not possible. I rest my case. Thank you so much.
Thank you, Speaker 3 from the opposition. All of your speeches are done. Now we'll move on to the reply speeches. The opposition will go first, and then we will have the proposition. I invite the speaker who is going to give the reply speech from the opposition to go ahead with their speech.
Yes.
Okay, just a second.
Just a minute.
Okay, who will be doing the reply speech?
I would be doing.
All right, okay.
Just a minute. Just a minute. Okay, yeah. I'll be doing the reply speech.
Okay, you can start whenever you're ready.
All right. So to sum up our stand as the opposition, we started with the special theory of relativity, and we went in a very systematic way. We started with the simple formula E equals gamma mc square. So basically, as any particle accelerates to the speed of light, this gamma factor keeps increasing, such that energy would be infinite to actually reach the speed of light, and this completely rejects anything classically accelerating to the speed of light. For something to be at the speed of light, it has to be a massless particle, which I do not see how it would make sense to have a spaceship that's massless. Then there are tachyons, which would theoretically always be over the speed of light, but the problem with that is that they cause causality. They could technically interfere with their own creation, and that is a mess, even theoretically. Then we talk about wormholes. Wormholes are still theoretical. They are, and even in theory, they are at micro scale. So again, a micro scale wormhole making this something like this at the scale of a spaceship is still very much impossible. Then we talk about when we looked at warp drives. Now, warp drives, the problem with Alcubierre warp drive was the negative energy, which would require exotic matter. Again, something which is completely in speculation. The warping of space-time, contraction requires positive gravity, but expansion requires negative gravity, again, which is completely not proven yet. And just think about, okay, just if we just disregard all of this and say a spacecraft is traveling out there in space at near the speed of light, think about the particles traveling in the opposite direction relative to it. The kind of damage that the spacecraft would have to would take from bombardment with those particles. How would such a spacecraft be designed? And next we looked at particle physics, where acceleration, we have accelerated particles to really high speeds, but it has not been possible to go to speeds over c. We have searched for superluminal motion out there in space. We have looked at jets from the black holes and stuff like that, but those have always been found to be below c. The neutrino experiment, which the second speaker mentioned, was found to have mistakes. So the thing we would like to summarize is that we are not against, as opposition, we are not against innovations, but we deal in facts. Okay. And I would like to conclude by saying that the government right now has only speculation, which is as good as science fiction. And we stand by our stance that going to speeds faster than c is impossible. Thank you.
Thank you to the reply speaker from the opposition. We will have the reply speech from the proposition next. May I know who is going to do the reply speech?
I'll do that.
Okay, you can start whenever you're ready.
Yeah, in a minute. So yeah. Okay, so I would like to talk about whatever the things they have been saying, the opposition have been saying. They have been continuously talking about the experimental evidence. Why there is no experimental evidence? We don't have any theoretical knowledge. Where are the experimental evidence? But the thing is, do we have an experiment evidence? Do we have an actual picture of a black hole before 2012? Did we actually discover? Did we actually knew what gravitational wave is? No. We experimentally, we now know it. But the only thing what I feel is they have been only talking about where are your experimental evidence, and talking about the theory, we don't have any theory. Are you saying that we don't have any theory? So what about string theory? Scientists like Michio Kaku, I'll quote myself again, Michio Kaku, Brian Greene have put their whole lives in these such theories. So you cannot say that we don't have any theories right now. We do have the theories right now. Talking about the wormholes, the GTR itself suggests the wormholes. So we do have a theory which suggests wormhole. Another thing being, to talk about what we do not believe right now. Einstein didn't believe that quantum mechanics or quantum world is in itself possible, that God doesn't play. He said that God doesn't play dice with the universe. So if someone like him doesn't believe in something, so of course, what we do not know right now, it is a possibility. It is a very big possibility in the upcoming, the future. Now talking about the future and multiverse, again I say string theory, there is a theory. String theory quotes that multiverse is possible. And what we have been saying, I told you, we were talking about the bigger picture. Whatever your facts are based on, it is just because on the GTR and STR basically, which I told already that these are what we know right now, what we are consistent. These theories are consistent with the known laws. But there is a possibility of the multi-universe. There is a possibility of warp drives. There is a possibility of wormholes. And I would again want to quote, whatever experimentally we do not have right now, it doesn't mean, because we, in this century, where we are, we have a lot of things like black matter, dark matter, antimatter, whatnot. But we don't have any experimental evidences. But that doesn't mean experimental evidence. We cannot just thrash all the theories that we have, all the work that other physicists did. We didn't say that Einstein is wrong or whatever he is wrong. We are saying there can be other physicists in the future, and there are physicists because there are theories. So just disregarding all these points, I do not believe. And I feel the only point that the opposition had was that they have GTR, and because GTR doesn't approve it, so they do not approve it. But I stick again, science, impossible things have been done before, and impossible things will be done in the future. So I rest my case, and I strongly believe what I said. Thank you.
I thank all of the speakers. I thank the proposition and the opposition. And since all of the speeches are done, I believe we have finished with the debate.
We are here with our grand finale round 2. We have Kepler's orbit, who will be speaking for that this house believes physics has not made any significant progress in past 40 years. Whereas Einstein's relativity will be speaking for this house has made progress in past 40 years. So, Gauri, please present the timer.
Is it visible?
Yeah.
Yes. So yeah, I would like to now hand it over to our chair judge, Hari. Hari, over to you.
Yeah. Good evening, everyone. So you can start, and all the best. So the government can start. Speaker number 1.
Just wanted to know, how will the POIs be there? They'll be raising their hands or they'll be speaking in between?
You have to unmute yourself. Also
Please do that. Like, and whenever I'm talking, just unmute yourself and say POI.
And that's it. You have to then again mute yourself.
No, like I'll be talking first, so I just wanted to know how will the other.
No, yeah.
And also all the participants, if you can, like, I think there should be one more. Yeah, okay. Now it's fine.
So you can start whenever you want.
In 3, I'll start in a minute.
Yeah.
So I'll start in 3, 2, 1. Good evening, panel members and all the judges today. Today, being this first speaker of the proposition, we believe that physics has made no significant progress in past 40 years. So today I'll be talking about how the physics is still stagnant there where it was since the time of Einstein and string theory. And my second speaker will be further elaborating on this topic, and the third one will will conclude and will tell us how we are, what our stances are exactly. So what exactly is the significant progress? Significant progress is, it should be large enough to affect a situation to a noticeable degree. So the problem being, whatever was left is still untouched. We haven't made any significant progress. I'll tell you what exactly the significant progress was in the field of physics. And I'm talking about this discussion. This discussion is only about physics and not about other sciences. Yeah, please.
You can go ahead.
That
It
was in
wasn't.
the,
It was.
What exactly is a breakthrough in the field of physics, I must say. Breakthrough was when Newton's theory was there after Aristotle, when he discarded Aristotle's theory. Another breakthrough was there when Einstein came and told everyone that Newton had some flaws, which everyone was afraid that it wasn't possible, and everyone believed in Newton at that time. But Einstein came and disproved everything. It was when the string theory came and further advanced things, which we do not believe. It was when quantum mechanics came into picture, which even physicists like Einstein was afraid of. And then when it came, this is what the actual breakthroughs are in physics. So this is what I am saying. What
POI?
we were, sure.
How do you define scientific progress?
Scientific progress. The scientific progress. I didn't told about scientific. We are talking about progress in physics, and I have already told about the definition of significant, what exactly significance is. So I don't think I'll go again in that. So talking about physics only, not other sciences. For example, be it quantum world, be it quantum world, the standard model of physics. The last theory which was put forward was in 1970, which was of Higgs boson. And still, we don't have any new particles. No theories are there which tell us about the new particles there. The only thing I'm sure the opposition must say that, okay, we have discovered Higgs boson in 2012. But I'll say, this is about physics. What discovery and experimenting actually is, it is concerned with the other sciences. Why couldn't we actually picture black hole in the time of Einstein? Because we didn't have those technologies.
POI?
So now we have those technologies. So which doesn't mean we are advancing in physics. We are advancing in other fields of life. Of course, we are advancing in fields like medicine, where
POI?
fields of medicine or engineering or commercial world, for example, we have barcodes and whatnot. Again, okay, sure, POI.
Are you implying that the discovery of the Higgs boson was not significant enough to count
What I'm
as
saying,
progress in physics?
again, I'll repeat, it is about significant progress in the field of physics, not in other sciences. So I guess I am sure of that. Now, what physics is actually based on, we know mathematics. So is mathematics changed now? Are we not using Lagrangian now? Are we not using Hamiltonian now? What are we using now? We are based, the mathematics is still old like that. So the whole ideas of physics which were laid upon the mathematics is still the same. So how are we exactly saying that physics has made significant progress? What I believe, when physics will actually progress is when they'll have a theory which contradicts causality, when they'll have a theory which will propose how we can actually move faster than speed of light, when we'll have theory of everything, which everyone wants right now, which is the goal. Okay, this is the goal, but they didn't do anything. It is still as it was in the time of Einstein and string theory. No theory have been proposed like that. So talking about whatever I said, I'll conclude whatever I said. Okay, significant progress has been done in other fields of science, not in physics. Mathematics is still stagnant and is still there, whatever it is. No theory has been, only whatever has been doing, it's just blending. And I must say blending is a bad word, not even the blending. So after putting all this, I feel I have put forward all my points, and I strongly believe that physics, we as a government strongly believe that physics has made no significant progress in past 40 years. Thank you. I rest my case.
Okay. The opposition can go. First speaker, whenever you are ready.
Oh, yes, I'm ready. Okay, so 3, 2, 1. So, good evening, everyone. I'm from the opposition, and we strongly believe that physics had made significant achievements in the past 40 years. So, first of all, I would like to counter the arguments given by the government proposition leader as the significant progress is made in the terms of Newton's theory, which are which had flaws, and then Einstein counter that and give his own theory. So let me clear this, that a new theory is given on the basis of the outcome that they came. So from a very influential quote by by Mr. Alexander, that even he discovered one at the first attempt he gets succeeded, but from 999 attempts which he was failed in, that are even more important than one attempt which he achieved, because those 999 attempts made made a important emphasis on that science is not about the exact results. It's about trying and getting new things uh, from the wrong theory. We derive very important conclusions from the wrong theories, and then we correct it, and then we gave the new theories. Then he said that that no new particles is found, no mathematics is increased. So let me clear this, that there is a lot of improvement in science, in a lot of not now a lot of improvement in the technology, in the quantum technology, which was made in the earlier field, like the quantum teleportation is the facility which comes in the 21st century. The 3D printing facility which comes in 21st century facilitates the science even more. And not only this, science is even related to other things which even yes.
How exactly is 3D printing and physics related?
Yeah, 3D printing is the science of like science is not only about physics, right? It is interconnected discipline, and as you said, that it is connected with other things, and you even denied that all the other fields are like developing, but physics is not developing. So that is not the case. If a field is interconnected, then it must develop with the other fields. Now, giving my points, like what are the achievements which physics does in this new era of the past 40 years is, first, we discovered, or we get the first image of black hole in 2015, and that is a big achievement of ours. Next, I want to say that we discovered the gravitational waves which were not even which were supposed to be there was theory, but that were not directly discovered. So directly discovering the gravitational wave is the biggest achievement of ours. We even have concluded the presence of supermassive black holes. By this, we achieved the isolation of the graphene element, which you said that it is interconnected part of the physics, like it is a interdisciplinary thing. Then we can say that evidence of the supercomputers, which helps us to understand the existing physical theory, is must and is very important in today's world. Then coming to the human genomes, which are really very which are really very yeah, which are very essential theories, and which are now become a practical thing in today's world. And in today's world come up with a lot of physical applications with them, a lot of implementations with them, and increase in humanity with the people. Even in the 20th century, yeah, we had a breakthrough through our Mars mission, where the humans reached the Mars mission, and it is even a great achievement. So summing up with my conclusion, that we strongly discouraged all the facts that the physics is not even not advancing and physics is not making achievements from the past 50 years. And I have given many theories which even relate the physics is really a very interconnected theory, interconnected subject, and it is progressive in the last 40 years. So I conclude hereby. Thank you.
Okay. So the second speaker from the government can start.
Thank you, Mr. Chairman. Am I clearly audible?
Yes, yes.
So I will be starting in 3, 2, 1. So first of all, thank you all of you for listening to us. And I, as the second speaker of the proposition, would like to again emphasize on the fact that we as the government strongly believe that physics has made no significant progress in the last 40 years. Before coming to my arguments, I would like to answer some of the questions raised by the first speaker of the opposition. They talked about that how Edison failed 999 times and then he invented the bulb. Yeah, that is true. We believe that science is a continuous thing. It is a ever evolving process. But here we are not concerned about where have we gone wrong, what have we learned. Here we are talking about that whether or not physics has made any progress in the last 40 years. And we again emphasize on the fact, no, that it hasn't. They talked about 3D printing. Again, I would like to quote this, that this is not a significant progress in the field of physics. It is a significant progress in the field of engineering, in the field of technological advancement. They talked about that the black hole image. Thank you. They talked about that we got the first image of a black hole. We verified that gravitational waves do exist. Yes, we believe that we got these things, but the black hole image could only be captured because now we have such amount of huge storage devices which could store such large images, and it is advancement of technology. I would emphasize my point again. Same with the gravitational waves. Now we have made technological advances so that we can verify the theories which were given ages back. They were given by Einstein in his theory, and we are now just verifying them with our current state of technology. Now, I would like to come back to my arguments. My arguments will be that physics as a field has expanded now because the amount of mathematics involved, we need, like, if we talk about string theory, we need higher amount, we need more advancement in mathematics departments to even consider about the other dimensions. We need more than 10 dimensions in string theory. And how can we make any progress if we still don't know how to progress in that area? I would like to talk about the theory of everything. That theory of everything, the way Einstein wanted to correlate all the things in the universe, and still we haven't made any significant progress. It is where it was years back. We haven't made any progress in the quantum model of gravity. We still don't exactly know how the quantum world functions. We are still very confused, and I would like to quote a very famous scientist like Richard Feynman, who says that even today I can proudly say that no one understands quantum mechanics. We still don't know the origin of our universe. We still don't know how our universe began. Big Bang is just a theory. We haven't had any experimental evidences to prove that. They talked about Higgs Boson thing. The opposition leader talked about that we discovered Higgs Boson. Yeah, but Higgs Boson theory was given in 1974, and we have just discovered it, and we have not made any new theories about it. Also, here I would like to ask for any POIs because my network connection is not stable, so I'm not able to see the screens of other participants.
POI? Are you implying that you don't count discoveries in physics to be progress?
Ma'am, I'm not saying that they are not progress, but I'm saying about any significant progress as the first speaker of the proposition defined. Significant is something which changes that how things we look at today and how we want to see them tomorrow. Physics has not changed. Physics has changed, and I believe that it has evolved. But the physicists still use the old props, the old methods to work on them. And still, since we don't have the required methods to explore that, then we can say that physics has become a stagnant field. Significant amount of effort is large enough that can make significant progress, which we can see like the ones made by Einstein, like when he he made up his point that time can be different from different observers. This was a significant progress, and I can't recall anything in the last 40 years which has changed the way mankind thinks about physics. We have not seen any changes in which we have just proved the old theories which were given in the 19th century, 20th century, and we are just proving them, and we have not made any significant progress. So we as the government strongly believe that physics has been a stagnant field for the last 40 years, and we strongly stand by our point. Thank you, and have a nice day.
Okay. Second speaker from opposition can start.
1 minute, please.
Yes. Okay.
Good evening, everyone. As the second speaker of the opposition, I firmly say that physics has made significant progress over the last 40 years. Firstly, I would like to point out some of the arguments that my counterpart in the speech too said. So she contradicted herself, firstly, by acknowledging the fact that theories are now being proven and used as technology. And at the same time, she's just negating the application part of physics. Let me put it very clearly in front of the house that we can have so many theories, but no proof. We can have so many proofs, but no application. And what is physics without application? Can we just neglect this whole portion of physics? Now, secondly, I think the first speaker of the proposition has just completely diverted the flow of debate by simply stating that all these innovations stated are just related to subjects.
1 minute done.
And there is no relation to physics. But let me put forth between to both the houses is that science has now developed into a very intradisciplinary subject, and any progress made in biology significantly means progress and more information base for physics and vice versa. So let us have a more broad view of this debate. Next thing that I would point out is that firstly, one of the speakers said about the theory of everything given by Einstein. Let me correct it. It's not given by Einstein, it is given by Stephen Hawking. And secondly, the speaker too pointed out to the futility of this theory. But let me put forth what Stephen Hawking himself said, and this has been also reiterated in the biopic which was just made last year. So when he gave the theory of everything, he wanted to prove and give one equation which could prove everything. I'm so sorry. He wanted to prove everything with just one equation. But let me put forth this, that after he said that, and he negated his own hypothesis that because he thought that it would never be possible to reach at such a theory, which the second speaker also touched upon. But after this, he did not become sad that, his theory that he put forth was simply rejected. He said, quote unquote, "I am glad that our search for the understanding will never come to an end, and that we will always have the challenge of a new discovery. Otherwise, physics would just be stagnant." Also, I would point out to the new technological and physical developments, because technology is just an application part of physics. Let me put it very clearly. And if we progress in physics, like I pointed out earlier, and we don't have the technological part through which we can realize it, it is completely futile for the mankind. And one such example where physics has really been helpful for the mankind, you and I, in the next 10 years, we can see that is the progress made in the electric cars. How can we not take into account this factor? So we have done significant progress in the V2G technology, which is a two-way energy exchange between the vehicle and the grid. We have made progress in the ultra-fast charging of the cars, and also in the lithium-ion batteries, of which we had no clue earlier. Yes.
Do you think that these methods have become popular enough for everyone to afford it?
Yes, ma'am. Actually, the thing is, you can just see one of the bikes coming out, and you can see it on the TV advertisements also. And that bike, that is an electric bike that is called a Geo Ride. It is very cost effective. Not only the initial price, but also when you use it for a couple of years.
1 minute left.
A lot of your expenditure. Now, coming back to other thing than cars, I would also like to point out one of the Higgs boson theory that both of the counterparts just mentioned. Let me keep it very clear. Two scientists known as Peter Higgs and Bosch, they confirmed that there had been these particles known as the Higgs particles, the bosons, which were in this Higgs field, and through that they were able to explain the origin of the mass of the elementary particle. And detecting this particle, CERN in 1994, which is not so earlier, approved the construction of a Large Hadron Collider that is known as the LHC, which is the world's largest particle accelerator, which is 24-kilometer ring in diameter, surrounded by 9,600 magnets. So I can't see any point with which the proposition can say physics has not made any progress in the past 40 years. Thank you so much.
Government speaker number 3 can begin.
Yes, sir, I'm ready. Okay, so good evening to everyone present here. We've been very happy because we've got a lot of information today, both from the proposition and from the opposition, and we're having a great debate here. But I'd like to clarify one thing about what the debate is actually about. It's not about progress in technology. It's not about progress or quality in standards of life, but it is about the significant progress in the physics world. As in, okay, let's all just open our textbooks and check. Do we have any theories stated after 1980? Can you see any word, okay, after 1980 or in 1980s or 1990s, these were the discoveries came, and that is how this theory came, and that's how we prove this? No, we may not find, I don't think at least we can even find one theory where we learn as in such, because we are stuck in an era where the major breakthroughs were done before these years. And we do not contradict the fact that there cannot be any theories in the coming future, or that science is stopping here, or we cannot find any theories. It's just that in the last 40 years, we haven't found anything yet. Contradicting or rebutting the points put forward, that the theories are not proven. If theories are not proven, how can it be effective? Yes, again, agreeing to the point, theories may not be effective. Yes, was that a POI?
Yes. So in 2006, some students at Duke University, they created a system which is known, they developed negative index of a refractive material which could redirect microwaves around a material. So how is not that a discovery in the past 20 years?
It's not about talking about discovery. Thank you for the question, by the way. It's not about talking discovery, but it's about the breakthrough that it can be seen. Has there been a very big discussion about this in the later future? As in, by talking about it, it's not the discovery that comes into context, but it's about the significant discovery or the progress that happens in the physics world. And that is what the discussion is having away today. So yeah, coming to the point which the second opposition speaker just put forward, that theories are not proven. We need experiments, and if experiments doesn't happen, theories doesn't hold away. So it works in a very cyclic manner, like if one doesn't exist, the other does. So if together it doesn't happen, see, normally everything or any kind of discoveries we see today is a blending of everything that has happened in the past. There is nothing been a discovery as in it has changed or blown away everyone's mind. And the black hole image, which was put forward by the first speaker of the proposition. Again, black hole, the concept of black hole was also introduced in 1920 by, just a second, let me just check for the name, by 1920 by a scientist. So sorry, I didn't note his name. Yeah, so which was again a theory, and it was a holdback or like a continuation chain of what was happening. And there wasn't any new discovery as in such. Then talking about the innovations, again, which is an interdisciplinary subject that has been happening science. Science is always interconnected, but we're talking about physics as in technology. When we take physics and application, it turns out to be engineering. And physics in certain, what innovations have we seen in the past future where we have seen physics as the main topic? Let me just read out the 15 most influential discoveries found, which is the DNA. Again, nothing importantly to do with physics, ATM machines, birth control pills, barcodes, and I agree to solar machines have been there, but how much has it been popular, or how much? Yes, it has been popular, but how much has it been affordable by the other people, and how much could they use it in their life? Physics is not something we stand back, or it's not that we can never find a finding over there. But the point we're trying to put forward is, for the last 40 years, nothing has happened other than just agreeing to the point or disagreeing to the point, or experimentally proving it. Yes.
Yeah, you are stating that the technology is not like related with the physics, but how could you explain the existence or the proven, how to you prove theories?
1 minute left.
You don't.
Yeah. Yeah. Okay. Fine. I get it. So the technology, yes, we need technology to verify things, and that is why we're being able to verify things today. And technology has helped it by that, but the technology by which it is made, does physics have anything to do in that case? That is the point we want to put forward. And in the last 40 years, we're taking it very general, the significant progress in the physics world. Physics world has been always good to toe checking or experimental value checking, or as in certain anything that would blow our minds away. And I am pretty sure that physics has not done anything as in certain, and that does not mean that that may not happen in the coming future. Definitely, we always have a chance for improvisation. But as of today, for the last 40 years, to be very particular, in that from 1980 to 2020 or 21, we haven't seen any such changes or any such innovations that can actually make physics above all the other subjects, and connecting it with technology would never
5
make it
minutes
better.
done.
Thank you and have a nice day.
Just a moment. Yes, so the third speaker from the opposition can begin.
Yes, sir. Good evening to everyone present here. I am the third speaker from the opposition, and we stand firmly against the belief that there has not been any significant progress in physics in the past 40 years. All the speakers of the proposition have asserted again and again the difference between physical progress, significant progress, and progress in the other fields. I would like to point out that I believe they are being too narrow-minded about what progress constitutes, focusing solely on lab results and not on discoveries, completely ignoring the fact that discoveries of the Higgs boson and gravitational waves constitute as significant discoveries. I also believe that, as the speaker 2 of my team has already mentioned, physics is a very multidisciplinary subject. At the atomic level especially, it cannot really be differentiated from chemistry and biology, something the great professor, Sir Richard Feynman himself said. The speaker 1 of my team, the opposition, gave a clear rebuttal to the claims of speaker 1 by giving examples of progress in quantum mechanics and other important fields. We cannot consider physics to be an isolated field, independent of all the other scientific ones. The speaker 2 of the proposition accepted that the discovery of gravitational waves was significant, which is contradicting their own stand, because I do not understand their differentiation between why their explanation of why discoveries do not constitute as real physical progress. They are talking again and again about the significant progress in things, but the theories which they mentioned, including the theory of everything and quantum mechanics, are very tough theories. A very less number of people in the world are supposed to have known this. Even Einstein did not understand his theory of relativity again. But how do you define significant in that? Is it a measure in something? Because see, these theories are very tough, and we need to accept the yes.
How can significant be connected with having it easier? I mean, how do you relate that?
I don't think I've implied significance in What I meant about these tough theories is that you are disregarding any progress in these fields simply because it hasn't been significant enough. But that is because these theories are very tough and it takes time for them to be understood. I believe that the public perception of science and understanding, as well as the education in physics, has increased exponentially because the world has connected with each other a lot in the past 40 years. And I think that does count as progress. The opposition as a whole believes that as long as we are learning, we are progressing, and that the sole definition of progress is not what are the lab results that we are getting. It includes applications, it includes understanding, it includes coming together with other fields, with other academic fields, which includes philosophy and religion, fields which were considered insignificant by physics for some time in the past centuries, but now more and more physicists and teachers and authors are talking about this and acknowledging our ancient knowledge, which I believe is proof enough for the progress of physics in the past 40 years. The speaker one of my team clearly mentioned the advent of supercomputers and how it has helped us in deepening our understanding of the existing physical theory. I would like to ask the opposition this: how do you define scientific progress, and why are you so adamant on defining it solely on the basis of
1 minute left.
existence of theories? The opposition has mentioned theories of Einstein, of Newton, and they are the only significant progresses which they have considered. But the proposition as a whole takes a very broad-minded approach of this and believes that physics, as well as being intimately connected with all the other scientific and academic fields, has definitely progressed in terms of not just lab results, but also in terms of applications and understanding. And that's where I would like to end my speech. Thank you very much for listening.
Yeah. So the opposition can begin with their reply. Whenever you're ready. So by the way, who is the speaker?
So the speaker two of Einstein's relativity, she'll be speaking soon.
Okay.
Should I start?
Yes.
Good evening, everyone. The opposition team has successfully reiterated and proved its stand that in the past 40 years in the field of physics, we have made significant advent. We have gone on to prove that progress in physics is not just a breakthrough, and it not only requires the advent of a completely controversial theory, it's a process of continuous learning, proving, and not proving of the theories. We also upheld the spirit of scientific temperament by being very optimistic, keeping in mind a very broad view, and also that progress in physics not only means coming up of new theories, but also, and it is an amalgamation of many lab results, by chance discoveries, understanding, application, and continuous learning and unlearning at the same time. We have also established a very multidisciplinary approach to science, keeping in mind physics as a subject and theory, which also was claimed by Richard Feynman. Also, through examples such as progress in quantum mechanics, discovery of the negative refractive index in Columbia, explanation of the origin of the mass of elementary particles through the Higgs boson, we have given scientific experiments, theories, discoveries, proofs of why we claim that physics as a discipline and field of study has made significant significant growth in the past 40 years. I think that we completely justified our position by providing the dates, the experiments, proofs, and giving it a very positive approach to the entire
1 minute left.
And thank you so much. I think I rest my case over to the government.
Government can begin.
Am I audible? Am I
Yes,
audible?
you are.
Yeah, audible. So, good evening again. I would like to start with the government, the opposition has completely changed the whole what this topic was all about. Physics, I had quoted in my first speech, I said physics is what we are talking about, and we are talking about significant progress. So these two terms, which we, the government, feel were the most important for today's debate, they just neglected it, and they just molded the whole arguments for their favor and trying to change the mind of the judges in the audience, which I feel they just didn't do justice with their debate and their points. Calling us narrow-minded, which again I feel isn't quite great. So the problem being, I again state physics, they are talking about physics being interdisciplinary and whatnot. But I already said this is the debate about physics, not about interdisciplinary. All the examples they gave was only and specifically about the engineering field and other fields. Be it, they never told another problem. I even said what exactly breakthrough should be and what not the government, but the physicist or the scientists believe what progress or breakthroughs are. And this, what we government feel, was what the discussion was all about. So just neglecting the whole argument and trying to just take the debate in their whole point. So what I feel is that they misread the topic, and they ruin the whole idea of this debate, and giving all the points which doesn't actually concern the physics in general, just concerning just the whole, whatever the whole points were, they were basically on how physics is interconnected. They said we talk about the bigger picture, but my dears, but I again say this was only about physics. So what I feel is that we still stand on what we said. We told about what significant progress actually is. We were fixed at the point of physics and not other subjects. We gave the arguments why physics is stagnant since 40 years, since the time of Einstein, since the time of when the string theory came, and nothing much in the maths, in the what maths physics is actually based upon is maths, has nothing changed a lot in that. So I feel we have put forward all our points, and we still agree on the point that physics has made no significant progress past 40 years, and it is just a stagnant field right now. Thank you. We rest our case.
Good. So congratulations to both of the team. Like you both the teams did really well. So should we move to the other room?
Yes, to the judges room. Yeah.
So we have the government, Einstein's relativity, who will be who believe that we may be living in a simulation, and ironically Faraday's, who are living in a cage, believe that we are not living in a simulation. So let's begin with the debate. Atul sir, it's over to you to get the debate in motion. Thank you. Before that, we want Sharon. Yeah, perfect. We have the time.
Yeah, so now I invite the first speaker from government to come and present.
Yes. Yeah, I'm starting. Yeah, 3, 2, 1. Like, I'm starting now. Yeah, good evening to everyone present here. Today's topic of discussion is that we may be living in simulation. We here refers to the humans. So we, the government, strongly believes that yes, we can live in the simulated world. So first of all, I like to define the motion of the debate. I will be talking about what is simulation and why we can say that we may be living in simulation, and my fellow teammates will give the evidences and all the project reference to this to establish our every point. So starting with my first thing, that what is simulation means. So simulation is not only the creation of something new, but it could be the recreation of something old, which could be done in order to understand the philosophical, the scientific, the social, and also it is used for the fun purposes. And we generate outcomes from these simulations, and we get to know about those environments. We get I can't hear. Is someone asking for PI? Okay. I'm sorry, but I can't hear. So what out, we generate outcome from these environments. Now, why are they beneficial, or what they give us? These simulations can provide us very
PY,
different kind. Yes.
Madam, how is this related to the debate that we are living in a simulation? Because you're just defining how we code we could code a simulation, but it is a reverse debate actually.
Yeah, no, actually, I stated the motion that we first talk about what is simulation. It is necessary to talk about what is simulation. Then we can proceed our talk. So I'm giving my definition already, that simulation is creating and recreating the environment which can be based on the scientific and philosophical thoughts. I hope your question is clear. And then I would like to establish my points by saying that in 2003 we had a great scientist which is named as Bostrom, which shows that the technological adept civilization, that that we have immense power of computing, and we need a fraction of power to simulate the new realities. Then by these theories, he proved that the probability that we are living in simulation is close to 1, and that's a huge number. That like probability
PY,
just a second, of simulation which is close to 1 is really emphasis on a living life which is simulation. Yes, please.
yes, but the same philosopher or scientist also opposed the AI the AI article that even Stephen Hawking blocked. Now, if we block the AI development, then how are we going to improve our computation?
You are asking that if we block AI, then how are we going to improve our computation? So let me clear my points, that simulation is not only about AI. It is having more other things, and we are not blocking anything in our way. We are not blocking anything in our way. The simulation hypothesis is also saying us that while the world we see in the some real sense, it is not the fundamental. It could be not be fundamental level of reality. And even the Elon Musk, who is a great entrepreneur and invested in companies, in many companies which are related to physics and simulation, also affirmatively said about this. Now, some thinkers also like Terrail is saying, it's the quote by Terrail, that it's ancient idea recast in terms of mathematics and science. It's not just a faith, it is a reality that we could be in simulation. So by giving these facts, I would like to conclude that this house believes that we may be living in simulation. Thank you so much.
Now I invite the opposition speaker number 1.
Yes, just
Oliver, you're not audible.
am I audible? Hello. Hello.
Better.
Hello.
Yes, you're audible.
Yes,
Yes.
speaker 1
Yes,
audible.
yes. We can hear you.
Good evening, respected judges, my worthy opponents, and all present here. We, the opposition, firmly believe that the universe is not a simulation, and now we will provide some arguments for the same. As the first speaker, I will talk about some simple definitions and arguments. Our second speaker will point about further points which will disprove the simulation theory, and our third speaker will concretize the arguments and convince you of our stance. Now, let's just begin with some simple definitions. What is a hypothesis? Which is what the simulation thing really is. So a hypothesis is a supposition or a proposed idea made using limited evidence, whereas a theory, which is what we prefer, which is what we use in physics, or in any science basically, is a system of ideas using general principles which can be verified. And basically, the first argument that can come to your mind against the simulation theory is just Occam's razor. I mean, it seems unnecessary to consider that you're in a simulated world. There's no evidence for this. No scientific puzzle would be solved with this. So you simply rule it out as being improbable. The next thing that you can look at is the kind of complexity that you would require to actually simulate a universe like this. The number of, yes?
Do you think that the differences which we have between reality and simulation exist on a more fundamental level?
That is a difficult question. But yes, I believe reality and simulation differ at a fundamental level, and I will come to that in my talk. So think about the complexity and the vast number of states which are required to be simulated in order to like give a convincing simulation of the universe. You could say that the universe is computing the laws, but then the question arises is there a higher law then? Is the person who is simulating the universe, then what kind of laws apply to them?
POI?
Okay.
How do you use the Occam's razor in supporting your argument that we do not live in a simulation?
See, Occam's razor simply means that if there is unnecessary details should be cut out of the argument. Now, you cannot see any, there's no, like suppose you are in a simulated world, there is no way that you can interact with the higher level, right? So it simply disregards that a simulated world cannot exist. That's the only thing that I have to say. So moving on. So the other point about this simulation hypothesis is that there are many civilizations. These civilizations build computers which run simulations of conscious beings, and since there are many more simulated conscious beings than conscious beings, there is a simulated world. But the problem with this is, think about the whole point is of complexity. A simulated universe, in a simulated universe, how can that sort of thing be possible? All right, because think about a simple example would be a game. Think about when you're roaming around in a game in a particular area, the computer would load the graphics and the area at that moment. But how would a universe be how would the physics of a universe work consistently in that scenario is the point of the argument basically. Another thing is that, well, the opposition speaker mentioned that that many famous scientists have, like, for example, even Elon Musk and some have sort of spoken for the simulation theory, but I mean, it's just their word on that, and and that's not how science works, right? We cannot just go about with someone else's word saying that, okay, this scientist says it, so it could be a possibility. And to sum up, basically, I would say is that mathematical rules. The mathematical rules govern everything that we see, but simulating something like this is simply not feasible, because think about the the difficulties in simulating a quantum system of atoms at like the size of the universe. That's all, thanks. Thank you.
Yes, now we are inviting speaker number 2 from government.
One minute, please. Good evening, everyone. We as a proposition team confirm to the fact that there may exist a simulation theory, and we cannot exclude an entire hypothesis or a theory that we have significant basis of from the scientific knowledge base. So first of all, both of my worthy opponents from the opposition team, they stated the name of Elon Musk, that there is a billion to one chance that we are living in this base reality, and then immediately refuted this claim. Let me go further and give example of a more scientifically knowledgeable person. So Nick Bostrom of Oxford University gave his simulation theory paper in 2003, which used Bayesian formula for calculation of this probability. So if we see this whole simulation theory hypothesis, its core is basically a statistical argument. It's a statistical theory. So we must look at this Bayesian formula that we have, which says that the simulation argument, which was posed by Bostrom, 1 minute, sir, it suggests that we may be living in a computer simulation. If post-human civilization have the capability and even the desire to have such a simulation, which Bostrom said in his paper, then the number of simulated realities would greatly exceed than the base reality that we are living in now, indicating that the probability of us living in this base reality is significantly low. So this, in simple words, mean that we are living in a simulated reality. Yes, sir. Your POI.
How is the simulation hypothesis different from God? Like you just are making someone a creator of the universe, and just giving it the name of simulator.
So first of all, God is more related to philosophy. It is the higher energy, and he's in our religious text and philosophies, he's taken to be only a creator. But here we are talking about a simulation. Basically, our thoughts, our activities, the entire movement of the universe is being simulated. It is being governed. It is completely different as if you talk about with God. Now, let me give an example for this for your better understanding. And the only thing that we will ever compare this simulation to God is just on the basis of that we cannot explain this, because it is a tendency of humans that if they are not able to explain anything with the help of the mechanical laws of this simulated universe, they compute it with God. This is what the people of Rig Veda did. Now, further explaining your point was, see, if we consider our space, the universe, as a simulated reality, let me talk about to you in number. So basically, what the energy, the matter, we, us, you, and me, we are a part of this simulated reality. Example, if matter is moving at any matter is moving at let's say 1,000 miles per hour, then basically that means that 1,000 miles worth of space per second is being transformed using some function, or you can say it is being operated upon every second. And that is being done by these extraterrestrial intelligence in intelligent words. So even our understanding in the knowledge of physics is also a simulation. So are the mechanical laws. Yes, sir. Yes, POI.
Yeah, but then how does the simulation theory help itself? Help us, anyways. This is just killing of curiosity, I would say.
Yes, sir. Sorry. The question of the debate is not why it is killing us or it is not beneficial. It is a theory which has been presented forth. And in this, we are at the disadvantage because we are being controlled. Because we see, let me explain you forth. We already have computers in our this base reality, which you call, for low level intelligences. For example, if you play a game, for example, Grand Theft Auto. So basically, we there have non-human characters in video games which we play. But in a sense, any algorithm operating on any computing machine would qualify for our thought process. So basically, we are like that character in that video game, governed by a set of laws and a processor speed. So it is already against us. So the question of the debate is also not to find out whether it is morally correct or immorally correct or to our advantage or disadvantage, but only to give forth that this exists. And also it is a theory. I think it is very much along with the scientific temperament that we accepted and not just refuted by saying that it is highly complex and unnecessary according to what speaker one of the opposition said. So that is how I'll rest my argument. And instead, we need to pay more attention to finding this extraterrestrial life. SETI, Search for Extraterrestrial Life, is doing that in this process. And I hope I gave all the arguments. Thank you so much.
Yes, now we invite opposition speaker 2.
Just a second, sir. Okay, before I start, I would like to counter the points the second speaker of opposition said. Am I audible?
Yes, you are.
Okay. I would like to counter the point. Like, do you really think that our life is similar to simulations that are played in GTA? Because do you really think that consensus be simulated? I would like to quote as our opponents tried to bring up a notable physicist's name to mark their words. I would like to talk about Hossenfelder. I hope I'm pronouncing his name right. A theoretical physicist have trashed the simulation hypothesis by saying that it's essentially a matter of religious faith disguised as scientific theory inquiry. So, okay, and as we all know, this is all based on philosophy. So, few philosophers even say that we do not have consensus experiences the same way the unsimulated humans do, or that it can otherwise be self-evident to a human that they are human rather than a simulation. I would really like to ask question to the opponents that if you're talking about some simulation, are you talking about who is making this simulation? Are you talking about as the speaker, the second speaker of the opposition stated, she brought up with something about the extraterrestrial life. Do you really think that some extraterrestrial life is controlling us? Are you really believing into Illuminati? So this brings the whole point, the whole debate into conspiracy theories, and this is whole pseudoscience. Yeah, sure.
How does Illuminati solidify the base for your argument?
The idea that what I asked is who created the universe, like who is controlling this simulation, who created the simulation, if you are living in it, if it's controlled by some entity, some alien life, some extraterrestrial intelligence life, then this is like a conspiracy theory which resonates to Illuminati, or is a we personally feel that this is a pseudoscience.
POI?
Yes.
You mentioned in the beginning that the search for if we are living in a simulation or not is based on religious questions, philosophical questions. Do you not think that religious and philosophical questions are scientific enough to be explored?
Okay, there have been attempts of trying to extract what the religious texts say and what religious things are about, but they do not qualify as scientific inquiry because it requires observations, it requires theory, it requires a whole set of work going on. Just because one scientist has came up with a paper, that doesn't prove that it's real, and there's no evidence about simulation theory being real. Uh, Anything more?
UI,
Yes.
your statement of this simulation theory not being true, doesn't it support the fact that it is a theory and must be proved? Doesn't this a sense of scientific temperament to be explored and not used not being true, these words?
4 minutes over.
Sorry, can you repeat? I would like the question to be repeated. Okay. Hello.
Yes, you're audible. I think what she meant was that you said that the simulation argument, the theory which has been put forth is not true. So is it a good scientific temperament to say that a theory is not true? Because we all know a theory can never be proven.
A theory can never be okay. The theories can be proven. General relativity theory was there and it was proven. Special relativity theory was there and it was proven. You can't just come up with some random, like someone's controlling us, some computer simulations are controlling us. That's not how it works in science. I hope you understand. I rest my case. Thank you.
All right, now we invite speaker number 3 from government.
Yes, so 1 minute. Good evening to everyone present here. I am the speaker 3 from the proposition, and we firmly believe in the idea that we may be living in a simulation. I'm here to further solidify our stand and refute the claims made by the opposition. The speaker 3 has given very unclear claims, has given very unclear arguments about the stand that he takes. He does not specify what he means when he says that simulation is just a religious and philosophical questions. I believe he is aiming at garbing our whole argument under by saying that it is just a philosophical question and not worthy of exploration. He further says that it is a theory. He further says that general relativity as a theory has been proven. Let me clear you on that. A theory can never be proven or disproven. It can only be verified again and again by experiments. One experiment goes wrong, the whole theory goes wrong. So general relativity has not been proven. The speaker 1 of my team was 1 minute. The speaker 1 of our team has said that the question is not how the simulation can be achieved. It is how it might be true. What is your POI, please?
Is simulation theory proven with any experiments been done?
No, not
like
yet. It is just a hypothesis. It is just a hypothesis, but that does not in any way support your stand, I believe. The speaker 2 of the opposition talked of the Occam's razor, but did not acknowledge the close to 1 probability of us living in a simulation about which the speaker 2 of the proposition successfully talked. The speaker 2 of the opposition justifies his stand by saying that us being in a simulation is too complex, which I believe is not a good scientific temperament. Computers, for example, were considered to be infinitely complex mere centuries ago. The speaker 2 of the proposition provided reliable scientific and statistical data for our claims, citing data from papers by great scientists. She also rebutted the claims by the other speakers of the opposition by giving logical examples and not simply basing her argument on assumptions, I would say.
AI?
Yes.
So you said that this whole thing of the point that the probability is 1, right? So it depends on this entire layer of simulations. Like there are simulations over simulations over simulations. So that layer of complexity, how do you explain that?
I do not believe your question is in any way directly related to my stand. The question that simulation might be too tough does not in any way justify us not believing that we might be in a simulation. The speaker 1 and 2 of the proposition mentioned Nick Bostrom, his paper on simulation, as well as the paper by David Kipping, in which he claims that the chances of us being a part of the base reality, of which which comes from the simulation theory, are very, very rare, which further justifies our stand. I would like to ask the opposition this. How do you differentiate between simulation and reality? And do you think that your difference persists on a more fundamental level? Just centuries ago, people thought a lot of things we are doing right now might be impossible. A lot of the things we believe in might be impossible, but they are possible today. How can you differentiate so solidly between reality and simulation? Why should anything on a computer not be taken to be as real as the plants growing around us? I believe that we have progressed exponentially in terms of computers, AI, and supercomputers, and that this is to go on. In the future, we might reach a place where we might be creating an alternate reality, which is very close to what we see right now. And then the chances of us creating that reality instead of us being a part of such a reality already created is being naive as well as ignorant, and believing that we are supreme beings who are a part of a very advanced civilizations, and that only we are capable of creating such a simulation, that another intelligence does not exist in this universe, which might have created this already. I would hereby like to rest my case. I believe that I have further solidified all the claims which the proposition has made using logical arguments as well as data and papers. I believe the opposition is going solely by saying that the theory cannot be true based on maybe the fact that there haven't been any proven experiments, or that it is too complex. I believe that is not a good scientific temperament, and I hereby rest my case. Thank you very much.
Yes, we invite speaker number 3 from the opposition.
So there was a dialogue in Three Idiots where the people were asked, "आप कौन से side से हो?" And they replied, "हम science के side से." And today the opposition is from that side. We are from the side of science. We are by the side of physics. We are not by the side of pseudoscience, pseudo-reality, and conspiracy theories. And what an irony that people who are from the side of science, from the side of physics, have been targeted by saying that we don't have scientific temperament. The government tried to present a lot of facts, but at best I think they could manage was a misleading propaganda. Let me tear through their argument one by one. The government is absolutely anti-physics, anti-human curiosity. The fact that the debate completely rests on the fact that later. I'll come back to it later. Yeah, the debate completely rests on the fact that even if the simulation hypothesis is to be considered, which is by the way a complete hokum made up joke, I would say, then to how does it help? How does it help us countering the physical questions of reality? How does it help advancing the endeavor of human intelligence is to advance, not to get muffled in the useless, baseless philosophical debates like if we are in a simulation or not. Yes, please continue with your POI. No POI? Okay, I'll continue.
No, Jasmine had asked the first POI actually.
Okay, I'll continue then. You will get the chance. You have 2 minutes. Yeah. Anyways, and the second point that I can see that the government is proposing, even though they don't stand by it, but in some ways they do propose it, that simulation is equivalent to God. Simulation, and even though if government tries to distance its stance from itself, this is proposing that there is a God, there is a supreme reality above us, which is governing our world, and we are some hapless creatures which are just running on its whims. And that's what the government stands by. We don't stand by. We are the opposition. We stand by physics, reality, evidence. We stand by practical experimentation.
UI.
Just one second. I would also like to raise one fundamental question over here. Has the government been able to even propose one experimental evidence? Now you might say that, okay, just because there is no experimental evidence, you should not discard the hypothesis or the theory. But there is a need for an experimental evidence. We cannot be believing on everything and anything. Then even ghosts are real, and everything is real. Then everything, because then there is no physics. Then there is no laws. Let's talk about everything. Yes, please go on. Sorry.
You said that, you know, believing in something unless we have scientific evidence of it is against physics, but we have infinite examples from the history of science where something was not believed in first and later proven to be true and completely changed our perceptions of reality. So is believing, standing by your claims, still supporting scientific temperament?
Yes, because even in those examples, the people who proposed excuse me, I think the 4 minutes are up, but yeah, anyways, the 4 minutes are up. I'm sorry. Replying to your POI, I think even in those examples, and I can state one example of Sir Albert Einstein, even though many people thought that his proposals were completely out of the box of the normal physics thinking, but still they had scientific basis, they had experimental basis, they had some use. Because of his proposals, we are able to use GPS. What does this? What are we to gain even if we believe that this is a simulated world and we are in simulation? This is not how we progress. As I said, for progress of human intelligence, for progress of human endeavor, we need a thought that has some scientific, that has some experimental basis, as well as some a foresight in future. All in all, all I can say is the government tried to present a good argument, but failed miserably on many accounts, and thus the opposition has a stronger point. Thank you so much.
Yes, we now invite opposition to reply.
Yes, sir. Just a second, sir. Okay. We will begin. We as the opposition put forward following arguments. We asked them about creator, who is the creator and the controller of this of our simulations. My first speaker are even defined about how what's the difference between a hypothesis and theory, and we even explained them how consensus cannot be simulated, to which we did not get any sensible counter arguments. They tried to speak about the religion and faith. They believe that some extraterrestrial life is controlling us. Wow, we have a new hypothesis here over here where we don't know that which alien civilization or the extraterrestrial civilization is controlling us. We don't know the location from where they are coming from. We don't know the planet they are. We don't know from which universe they are speaking from. They, yes. They are clearly they can they have clearly no idea about what they are talking about. Okay. The opposition only presented just a scientific, just talked about just one scientific paper, and they have no proofs about how the simulations are working. Like they even try to compare our lives with the lives happening, the ones that's happening in the games, simulation games like GTA or the SimCity. We even we again stress on the points that concises cannot be simulated, and we need to have evidence that how concise how the paper puts forward about the concises that the opponents are talking about. Okay, I rest my case. And I think that we have put I have stood by our position that we do not live in a simulation. It's all a pseudoscience, uh, conspiracy theory, and just ridiculous. Thank you.
Yes, now we invite government to reply.
So Speaker 2 of government will be speaking. Let's start soon.
Good evening, everyone. We, as the proposition of the government today, first provided a solid base as to what the meaning of simulation is. We then proved through the Bayesian formula how we have 1 in a billion chance of us living in a based reality, which is backed by papers by famous scientists, including Nick Bostrom and David Kipling. We also established that it is not that the extraterrestrial intelligence does not exist and there's nothing like simulation, but it is that our efforts are lacking in this field, and the time that we have devoted simply to this theory of simulation and the search for extraterrestrial intelligence is very small if we see on an astronomical time scale, and you can have nothing out of the box in a fraction of few seconds talking about the astronomical time scale. Also, according to our team, we logically explained and drew comparison between two set of claims. And those two set of claims are as follows: that just as we have been advanced and we have computers running all kinds of simulation for the lower level intelligence using algorithms, some species or form of intelligence fundamentally more advanced than the human race might be doing the same to us, of which we have no clue at all. So I think all in all, I will reinsert the claim of our team that we went along with the spirit of scientific fervor, the spirit of inquiry, which has been reinstated by all the scientists named so far in this debate. Also, I would like to give example of Higgs boson in this end, that Higgs boson, which has been recently discovered particle which shows the sign of origin of mass, was known as the goddamn particle by the person who discovered it. But we know it as a god particle today. Why? Because for so many years it was believed that it is not such a particle, and the scientists were so frustrated. So why not this spirit of science we continue for this theory? And we have had taken this stand forth. At the end, I would reinstate something stated by Carl Sagan, the Nobel Prize winner physicist, that the no theory of existence does not mean theory of non-existence. Let's continue our spirit for science. Let's continue finding more and more stuff. It is just the beginning, and I hope I have cleared my stance as the proposition. I hereby do rest my claim. Thank you so much.
Now I would like to call upon our professors to finally announce the results. So firstly, I would like to call upon Rohan sir to call upon who is the second place. So Rohan sir.
Hello.
So over to you now. So yeah, just a second. Just a second. I'll message you who has been placed second.
Okay.
And
Yeah. Before I announce, I just want to say a few words about the Society of Physics and the event. That I have seen Society of Physics, means not only me, the whole department has seen Society of Physics from its inception in 2018, where it started as a kind of a very kind of a idea which was, that time it was quite raw and we were not knowing whether how it will go ahead in time. But I'm really happy to see that the events they are organizing as a society, as an organization itself, has progressed to a totally new high level. And I can see from the involvement of all the students from BSc as well as our MSc students who are involved, even many students who joined the MSc course last year, now they are actively involved in the whole process of organizing and being a part of the core committee. So that says how strong contacts have been created between the different students of the department, which was not possible by a regular schedule. Means we come to the class, we have lectures, practicals, which is where interaction is normally from the student to teacher, or even between the student, it's just between the about the work. But here it is beyond that. So I feel the Society of Physics is playing a role where students can interact with each other, they can share information about the career opportunities, about the different resources related to the subject. Okay, and also because everyone is getting involved, it also increases the interest about the physics. It is changing the way everyone look at the physics as a subject. And this event, I feel that it's really a very good event because it gives you a wing to imagination, because you are debating with someone, so you have to put your own things, not like regular teaching where you have a reference book or something where something is already written. Here is something you have to think and put forward, and also you have to defend sometime, or you have to argue with someone else, so that you're pushing it is like pushing your limits. And I really feel good that you guys are arranging these things. And as a professors and as a part of a regular system, these things may not be possible from our side. Means we can arrange that, but it is like if you guys arrange it, it becomes like kind of, it can expand to a level which we can't do, frankly speaking. Yeah, so I'm really feel good about this. Okay, so let me announce the winner. You send it on me to me on it is in chat. Oh yeah,
yeah.
It's Kepler's orbit. So say this is a this is third second place. Second place is to Kepler's orbit.
Congratulations, Kepler's orbit.
Kepler's orbit.
a lot.
Thank you.
Congratulations.
Thank you, sir.
Thank you so much.
Congratulations.
Thanks a lot. Thanks.
Thank you.
Keep
Thank you so much.
participating.
Congratulations.
Yeah.
Keep participating and keep involving in different events related to physics.
Sure. Thank you.
Thank you. Thank you, Jay.
Okay,
Thank
so
you to the
I would
Society of Physics.
just like to mention. Thank you so much. Yeah. So I would just like to mention Kepler's orbit. They belong to Lumen, the Physics and Electronics Society of Hansraj College. So congratulations, Hansraj College, for being placed second. And and yeah, I would. Sorry.
That was a promotion for us now.
Yeah, sure. So moving on to the first place. So it's between Faraday's cage and Einstein's relativity. I would like to say like the difference between the second place, that is Kepler's orbit, and the first place is, I guess, just 8 points. Like you were scored out of 1800 points today. So out of 1800 points, it's just a matter of 8 points. That's not even 1 point when we consider it 200. So that was really close. And so I would now like to call upon Jyoti ma'am to announce the winner of Repulsion 2021.
Actually,
Ma'am, it has been sent to you on
I
WhatsApp.
kind of had gone away for last few minutes because some emergency in the kitchen, and this is what happens when you're working from home. So I really didn't hear what all you announced. So then now, please ask Shamla madam to do the needful. I just came when you said that you are asking Jyoti ma'am to announce. I'm sorry.
Ma'am, yeah, we have like sent you the winner's name in your personal chat box on the Zoom.
Oh,
you have to announce the winner on WhatsApp. Yeah, on WhatsApp it has been
on
sent.
WhatsApp. Okay, let me check.
Everybody be ready, unmuted to clap for the winner. Yeah.
Okay, so yeah, I have read the message, and I'm very pleased to announce that Einstein's relativity is the winner.
Congratulations.
Congratulations.
Congratulations,
Congratulations,
guys.
Lively debate happening here, and really great work done by the Society of Physics and all the volunteers and the judges and so on and so forth. I have just come on the last day and announced the winner, so I almost feel guilty of not deserving to be the one to announce the winners. But yeah, thank you for giving me this opportunity. And you people are doing really great work, and I'm really happy that a lot of interesting things are happening among the students, and very active work is happening. So keep it up. Yeah.
Okay, so let me reveal which college Einstein's relativity as well as Faraday's cage belong to, because Faraday's cage, congratulations to you too, because you have anyways landed in the third place. So yeah. So Einstein's relativity, they belong to Vidyut, Miranda House. Right?
Oh wow! Congratulations.
Okay, any guesses where Faraday's cage belongs to? Which college?
I think
which
when
society?
I saw Faraday's cage, Oliver Pereira there, that means it is from Xavier's College.
Yes.
Okay. That just happened. Like I made a mistake in one of those Faraday's cage competition. By mistakenly, I called by name Saurabh, and I was like, "Oh man, I made a mistake. I just revealed I know him." But thankfully, no one took a note of it. But yeah, now you can like Mel Milab this year, that college, everything is open.
So yeah, not a lose for organizers too. Yeah, we have also placed third. So yeah. So yeah, the game is not over yet. We also have one more title, that is for the best speaker. And the best part about the best speaker that it is plural. We have a tie for that. There are two best speakers that we have, and I would like to call upon Shamla ma'am to announce both of them.
Yeah. Just before that,
Yes.
sorry, ma'am. You can go ahead, ma'am. You can go ahead. I'll say after.
No, it's okay. You can complete. Yes.
Okay, I'm so excited. I just want to boast about that. I guessed both the speakers, and I'll say that I put in a core group. I want these two people to win the best speaker, and I'm happy. It came to judges also came to this conclusion that you both are the best speakers. I was personally very impressed by that, and I was rooting for you both guys. So I'm really happy there are two. Okay, that's what I wanted to say. I'll shut up.
Last one.
Okay, I should
Yes.
first say that Society of Physics is really doing a very good job. You are coming up with very good activities, especially this particular activity. It was not at all a small, simple activity to be completed in a day or in an hour. You all have taken a lot of trouble, and I'm happy the way you all are working together. So all the best, not just to the Society of Physics, but to each and every individual member of Society of Physics for all their future ventures. And I should congratulate all the 17 teams who participated, because it is always known that only one or two will get the prize, but that does not mean that others have not put in efforts. Okay, so everyone I should congratulate. Now let me announce the two best speakers. One is Jasmine Kaur Chahal from Miranda House, and second one is Nilay from Xavier's College. So congratulations to both of you, and again congratulations to all the participants. Thank you.
Thank you so much.
Okay, over to you, Jay.
So congratulations to all the speakers and all the ones who have participated, the organizing team, the professors. We are really thankful to you for making this event a success. So with this, I guess we can conclude with the session if you guys don't have any doubts. And yeah, thank you everyone.